graphs are 1 over the equation, correct? So what was the original equation if this is a reciprocal? If this is a reciprocal, nope. Technically, yes, actually, but
x, y equals
yeah.
x plus
So the original would be y equals x. Would be y equals x plus 3. So your original would be y equals x plus 3. And reciprocals are just, the definition of a reciprocal is just y equals 1 over f of x. And f of x is just your original equation. Now the cool thing about this year is we've only done linear in grade 10 and quadratics in grade 11. So when we do reciprocals, it can only be 1 over a linear or 1 over a quadratic. It's not going to be like 1 over any other random equation. Switching 30, you can do radicals. We can do any function underneath it. In 20, we can only do a linear and a quadratic. Okay? So that's a reciprocal. 1 over something. And then the original function would be the one that's underneath. Right? Okay. Now, vertical asymptotes. Vertical asymptotes are based off of what? The denominator, because vertical lines are x equals lines. Horizontal lines are y equals lines. So our horizontal asymptote is y equals. Okay? So this function, what would my non-permissible value be? X cannot equal negative 3. Because we go x plus 3 cannot equal 0, x cannot equal negative 3. That would be my NPV. Kind of reviewing a little bit of rationals here. So my asymptote is equal to that, remember? So my asymptote is equal to that. So it's equal to negative 3. Okay? My horizontal asymptote, if my numerator is a smaller degree than my denominator, so how do I say that? If my numerator is a number, my denominator is a variable, then what is my horizontal asymptote every single time?
y equals 0.
0. Okay? So if my numerator is a smaller degree than my denominator, so my numerator is a number, my denominator is a variable, it's going to be y equals 0. We agree? Okay. So that's if my original was linear. We agree? What if my original was a quadratic? Well, I could say the reciprocal is y equals 1 over x squared minus 3x minus 4. So my reciprocal is 1 over that. What would my original be? If this is a reciprocal, y equals x squared minus 3x minus 4. It would be the equation on the bottom, because remember, a reciprocal, you just do 1 over the original equation, right? That's what the definition is of a reciprocal, is 1 over the original equation, because that would cause the original equation to flip. Now, if this is my original equation, or this is my reciprocal, I need to factor my denominator. What multiplies can be negative 4 and adds can be negative 3. X minus 4, x plus 1. So now it's in factored form. We agree? So we have vertical asymptotes. And horizontal. Vertical asymptotes are x equals, horizontal asymptotes are y equals. What's my horizontal asymptote for this one? Y equals what? 0, because my numerator is a number, my denominator has variables, correct? So reciprocal functions actually always have a horizontal asymptote of y equals 0. Reciprocals will always, because they're going to be a number over an equation. An equation will have a variable, right? How do I get my vertical asymptotes? They're always from my non-permissible values, so that's why I had to factor that. So my NPVs for this one, I'm going to have x minus 4 cannot equal 0, and x plus 1 cannot equal 0. So x cannot equal 4, and x cannot equal negative 1. So my asymptotes are at 4 and negative 1. So I can have more vertical asymptotes than horizontal. But if I have a vertical, I have to have a horizontal. You can't have one or the other. You have to have both. You can have more, but you can't have neither. The other example I gave you was, what if I gave you this? Y equals 3 over 2x plus 1. Is this a reciprocal? No, because there's a 3 on the top. It has to be a 1. The definition of a reciprocal is y equals 1 over f of x. We agree? Is that a 1? No. So this is a rational graph, but it's not a reciprocal. Okay? So I want you to give me the asymptotes for this one, vertical and horizontal, and I want domain and range for that one, and I want it for this one. So I want the asymptotes and the domain and range. We did this yesterday. Try it out. So the first one, my vertical asymptote, is x equals, well, we have to take our denominator, 2x plus 1, and this would be a linear on the bottom, equals 0, 2x equals negative 1, or not equal to, and x cannot equal negative a half. So the graph does not exist at negative a half, right? So that's where we draw the dashed line that doesn't exist, which is the asymptote. So the graph doesn't exist there, but the asymptote does. That's why we put the equal sign. Okay? Once you have that, your domain is easy. It's just x such that x cannot equal negative a half. XER. Now your horizontal asymptote. So this is set notation. You're going to learn interval before you leave for the year because you're going to need it for grade 12, but I'm letting you just do set for now. My horizontal asymptote, my numerator is a number, my denominator is a variable, so my asymptote is going to be at y equals, nope, numerator is a number, denominator is a variable, it's always y equals 0. So my range is going to be y such that y cannot equal 0, y. So it's whenever the numerator is a lesser degree than the denominator. So the denominator is degree 1 because it would be x to the 1. The numerator would be x to the 0, so it would be degree 0. So it's less. So whatever the top's the numerator, the bottom's the denominator. Now, for this one, we have a vertical asymptote. So we go 3x plus, oops, that's not true, 3 plus 4x equals 0, 4x equals negative 3, x equals negative 3/4. Domain x such that x cannot equal negative 3/4 XER. And then we have a horizontal asymptote. Which is going to be at y equals, and this one is actually what? The degree of the numerator is the degree of the numerator is 1. The degree of the denominator is 1. They're both here, so I take the fraction of their leading coefficients, which is going to be negative 2 over 4, which reduces to negative a half. You can take a 2 out of both. Do you see that? So when they're the same? Yep.
So you can get like from the one that's the variable, not like the one that's the
Right. Because we need to take the leading coefficients. And the leading coefficients are always, it's a fraction of the leading coefficients. The leading coefficients are the coefficients that are in front of the largest exponent. So if it's x to the 1 and x to the 1, we find those and take the fraction of those. Yeah. And then our range is y such that y cannot equal negative a half. Y here. So does everyone remember that now from yesterday? Coming back? Okay, so we're going to go to our notes where we left off after those questions that we did. So we're going to go to here. Example 2. It's page 5. So we focused a lot yesterday on asymptotes and domain and range, correct? Not as much on graphing, so today we're going to go over graphing a little bit more. But we need to understand our asymptotes really well to help us with graphing. So here it says consider f of x equals 2x plus 5. And then I say determine the reciprocal function. Remember the reciprocal function, if it says that, that's just y equals 1 over f of x. We agree that's the reciprocal function, 1 over f of x. Whatever f of x is, we put in the denominator, and in the numerator we put a 1. Because reciprocals just cause the fraction to flip. And the way you cause a fraction to flip is to go 1 divided by. Are you ready to write? Okay. So, we're going to go y equals 1 over 2x plus 5. I want you to get me the asymptotes, both asymptotes, and I want you to get me the domain and range. Our vertical asymptote, and I can write VA because these are my notes, and I can shorthand in my notes, correct?
Yes.
On unit tests, can you shorthand? No. On diplomas, can you shorthand? No. So we want to get everyone out of the habit of writing any shorthand words on unit tests, okay? Because when the diploma comes, if I write VA, they will not give you the marks for it because you're assuming they know what it stands for, okay? So we're not going to short form, but we can short form in our notes because there are notes and we know what our notes stand for, right? So that's totally fine. So my vertical asymptote is going to be x equals negative 5 over 2. We agree? Correlating that would be my domain. My domain would be x such that x cannot equal negative 5 over 2 XER. So at negative 5 over 2, which is negative 2.5, right, I am going to have a vertical asymptote. So I'm going to go to where x equals negative 2.5, which is approximately here, and I'm going to make my little tick, correct? My little tick at negative 2.5. Does that make sense what I just did? Now that tick is a vertical tick, isn't it?
Yes.
And it's going to extend itself upwards and downwards into a vertical dashed line, which is my vertical asymptote. That's why it's called a vertical asymptote, not horizontal, even though it's x. Because I extend this little dash, I extend it up, so that all of the negative 2.5, and I put an arrow on it, it's going to keep going for all of negative 2.5 and I'm going to label it so that I know. So that's my vertical asymptote, and it's at x equals negative 5 over 2. So that's like the electric fence for the cattle. Remember, you can't cross it. It's actually not there, right? It doesn't exist. It's just an imaginary fence that you can't do. So at negative 2.5, I have the fence. Now, my horizontal asymptote is y equals 0. If it's a reciprocal function, that should make you happy. Because reciprocal functions, the horizontal asymptote will always be y equals 0, because reciprocal functions always cause you to have the number 1 over a function, and a function has an x, or a variable, correct? Whenever we got a number over a variable, we got y equals 0 every single time. So every single reciprocal graph, your horizontal asymptote's instantly done. It's y equals 0 every single time. That's the great part about a reciprocal. Enjoy it, because there's other things that aren't as fun. But that is. So our range then will always be for a reciprocal y such that y cannot equal 0, YER. And then I can short form once again because it's mine. The next thing I always do, so I get my asymptotes first. That's when I go to draw a graph. First step is going to be asymptotes. Second step is going to be determining invariant points. Where did invariant points happen at? Do you remember? Y equals what and what? There's two of them. And I'll give you a hint. The two numbers stay the same, because that's what invariant means. And when you do reciprocals, you do 1 divided by the number. Correct? and that number will stay the same when you divide it by 1. So when you go 1 divided by these two numbers, you're going to get the same number. Anyone remember what those two numbers are? Reciprocals are 1 divided by a number, yeah. 1 and negative 1. Because if I go 1 divided by 1, I get 1. If I do 1 divided by negative 1, I get negative 1, right? So invariant points on a reciprocal, and this isn't for every single case if they ask you invariant points next year. It's for reciprocals because 1 divided by 1 and 1 divided by negative 1 stay the same. So my invariant points for reciprocal graphs happen at y equals 1 and negative 1. So I'm always going to do two cases. I'm going to do two cases. I'm going to do one where y equals 1 and then solve for x. And I'm going to do one where y equals negative 1 and then solve for x. Now, if they remain invariant, that means they're going to be the same on either graph, correct? The point's not going to change. So I can actually go up there and plug it right into my original. My original is y equals 2x plus 5. That's the original equation, y equals 2x plus 5. I'm going to go 1 equals 2x plus 5. And then I'm going to go negative 1 equals 2x plus 5. Because I set y equal to 1 and y equal to negative 1 and solve for my x's. So when I want invariant points, if I ask you to determine an invariant point on the test, you have to set the equation equal to 1 and negative 1, and then solve for x. So for this one, I'm going to subtract 5. I get negative 4 equals 2x. I'm going to divide by 2. I'm going to get x equals negative 2. And then my coordinate is going to be at negative 2 and 1. So I can go over here. I can go to negative 2 and 1, and I can plot a dot. Because I found it. It's invariant. It's not going to change. Then I need to find my other one. So I subtract 5. I get negative 6 equals 2x. Divide by 2. X equals negative 3. So my other invariant point's at negative 3 and negative 1. So I go to negative 3 and negative 1. And there's my other invariant point. So I know the graph is going to exist. Remember the graphs always exist across from each other? Rational graphs, also known as reciprocal graphs. These ones are specific rational graphs. They always exist opposite each other. So these ones are existing bottom left, top right. Correct? How do I get more points to graph this? How do I get more points? Type this into my calculator. I can pull points off my calculator. Type that in. Y equals 1. Now, if you don't use alpha y equals enter, the fraction button, you have to remember to put your denominator in brackets. So everyone's typing it in. So I always do alpha y equals enter because I have the newer one on here. And then I just have the fraction and I don't need brackets. Now this is something to note. This is something to note. If you have the new calculators, if you use alpha y equals enter and you type it in as a fraction, your table of values will pop up as a fraction and sometimes harder to draw. If you want your table of values to pop up as a decimal, clear that out or leave that in y1, and in y2 go 1 divided by bracket 2x plus 5. If you just write it as 1 divided by 2x plus 5 and you go to your table, if you have the newer calculators, it'll then give it to you in decimals. You see the difference? So you could put it in alpha y equals enter in y1 and in normal in y2 and use decimals. Yeah?
I'm just wondering where the negative one from. Like for when it says negative 3 and negative 1.
From here, we plugged in a negative 1.
So then just count that as our...
Y. Because we're subbing in our y as negative 1 and we're finding our corresponding x. Yeah. So I know I have like negative 7 and negative 0.1114. I know I have negative 6 and negative 0.14, so that's close to. I have negative 5 and negative 0.2. I have negative 4 and negative 0.3. Negative 3 and negative 1. Negative 2 and 1. Negative 1 and 0.3333. 0 and 0.2. And then they just get closer, right? So if I want to, if I was a cow, remember, and these are the spots I can go. Once I hit this spot, I just ride along the fence trying to find an opening, right? And if I'm a cow, I'm going to try and ride along this fence and hope to find an opening as well. But I'm never going to find an opening because it keeps going off for life. Yeah?
Are you finding these like off of the table? Or
Yes, off the table.
how do you see?
Second graph. So if you used alpha y equals enter and you use the fraction, your answers in your y1 are going to be fractions. So I typed it in, I retyped it in as 1 divided by bracket 2x plus 5 bracket, and then it put my answers in my table in decimals. So it was easier for me to draw it. Do you have decimals or fractions? So it's because you're using the proper fraction. So in y2, I would suggest you leave that in y1, so you still have the fractions. Then in y2, retype it the old calculator way. So go 1 divided by bracket 2x plus 5. So then your y1 will be in fractions, and your y2 will show the decimal version of that fraction. So you'll have both, which is nice. Now this one, once again, we connect and then we ride along. And then here we connect and we ride along. And there's our sketch. So we graphed it. And the domain and range we already did, because once you have the asymptotes, domain and range are instant, right? So honestly, I think the hardest part of the new stuff we're learning today is just getting the invariant points. Setting each equation equal to 1, negative 1, solving. That's the only new stuff for today. Everything else is repeat from yesterday. Okay? So my domain, just going to rewrite it down here, x such that x cannot equal negative 5 halves. And my range, y such that y cannot equal 0. This one says try. We're going to try it. We're going to do quadratic. Yep. Yep. So try this one out. Everything, you got to do it all. So we have determined the reciprocal function. So the reciprocal function would just be y equals 1 over negative 3x plus 2. And right away I could type that into my calculator and look at it so I know where I'm headed, right, if I want to. I want asymptotes. So the vertical asymptote, not sure why I'm writing it this time, vertical asymptote is going to be x equals, move the 2 over, divided by negative 3, you get negative 2 over 3, or 2/3. Just positive, right? My horizontal asymptote is going to be y equals 0. Every reciprocal function, it's y equals 0, right? So that's the first thing I'm going to go sketch. Y equals 0 is the x-axis. X equals 0 is actually the y-axis. They're the opposite axis. That's the horizontal asymptote at y equals 0. And then I have a vertical asymptote at 2/3. So that's a guesstimate. I'm going to guesstimate it here. Then I need my invariant points. Invariant points on a reciprocal graph happen at y equals 1 and y equals negative 1. And I can just plug it into the original, which is y equals negative 3x plus 2. The reason why I can plug it into the original and I don't have to plug it into rational is because if it's invariant, the point should be the same between both, correct? So I'm going to use the easier equation to find the x. So I'm just going to use the original to find it. So I'm going to go 1 equals negative 3x plus 2. And then I'm going to go negative 1 equals negative 3x plus 2. When I solve this one out, I'm going to get something in 1. When I solve this one out, I'm going to get something in negative 1. Because that's the y's I put in. Do we agree? Okay. Then I'm going to subtract 2. Negative 1 equals negative 3x. divide by negative 3, x equals a third. So I have 0.333333 and 1. So it's like somewhere here. This one I'm going to subtract 2. Negative 3 equals negative 3x. Divide by negative 3. X equals 1. So 1 and negative 1. Now it's an opposite quadrant, right? How do I get the rest? Well, I type it into my calculator. Where's my calculator? So I go 1 divided by negative 3x plus 2. And I get negative 6 and basically 0. But it's positive. So it's just above. And then negative 5 and just above, negative 4 and just above, negative 3 and just above, negative 2 and 0.125, negative 1 and 0.2, 0 and a half, 0.5. And then I'm just going to be the cow that walks along the fence. Or pretend that's a straight line that did not curve back a bit, because I did a really bad drawing. Then I pull more on the other side, so I go 1 and negative 1, 2 and negative 0.25, 3 and negative point, these get really close. So I'm going to follow it along down here with an arrow at the end, and follow it along here with an arrow at the end. That's graphing it, and then I need the domain and range. My domain is going to be x such that x cannot equal 2/3, XER. My range is going to be y such that y cannot equal 0, y here. Then we're going to flip over and we're going to do a quadratic. Okay, so we're going to do the exact same things. We're going to state our asymptotes. We're going to get at our invariant points. Now this is the catch. This is going to be quadratic, so we're going to have to solve it like a quadratic, which means more work. And then domain and range. So we do the same thing. So its reciprocal is going to be y equals 1 over x squared plus x minus 2. I factor my denominator. I'm going to get 1 over, what multiplies to give me negative 2 and adds to give me 1, x plus 2, x minus 1. Now we've went over this already with asymptotes, so this isn't the hard part. I'm telling you, the only new thing that we're doing today is sketching it, which we kind of did yesterday, and then invariant points, solving algebraically for invariant points. Okay? So here we're going to get a vertical asymptote at x equals negative 2 and 1, and a horizontal asymptote at y equals 0, because it's a reciprocal, and when it's a reciprocal, it's y equals 0, because the numerator will always be a 1, our denominator will always have some variable in it, right? So that doesn't change. I can even do my domain and range right away. X such that x cannot equal negative 2 and 1, XER. My range, y cannot equal 0, YER. Nothing different than before. So we're going to do that. Then we need to sketch them. So this time we're going to get 2 vertical lines that are dashed, because we have 2 vertical asymptotes, and still the one along the x. So we're going to get this one along the x, which for reciprocals it's always going to be on the x, because it's a horizontal asymptote at y equals 0 and it never changes. And then we're going to get 2 verticals. One's at negative 2, so I go to negative 2 on the x, do a dashed line, follow it up. And then my other one's at 1. So I go to 1, do a dashed line, and follow it up. Ooh, pretend those are straight. Now I can sketch it without my invariant points. I'll show you. So type this into your calculator, making sure that you can just type the original in. So you could type this one in. You can go y equals 1 divided by, in brackets, x squared plus x minus 2. The trinomial has to be in brackets. So everyone's going to type that in. So everyone's typing that in and then following along with me. We get x squared plus x minus 2. Then press graph so you can kind of see what it's going to look like. It's going to run along the x-axis, curve up. It's going to make kind of parabola going down. It's going to run along the x-axis going out. That's what it looks like to me. So that's what it should look like to you. So I'm going to start at -8. I work from left to right. So I start at -8 or -10, whatever. They're really close to the x-axis. So if I go to -8, 1, 2, 3, 4, 5, 6, 7, 8. -8 is 0.01, so it's just above the x-axis. It's positive still. -7 is 0.0, just above. -6 is 0.03, just above. -5 is 0.05, just above. -4 is 0.1, still just above. -3 is 0.25, and then it errors. So it's going to kind of like, I wish I didn't pick red. So it's going to come along here, curve this way, and then curve, the cow's going to walk along this electric fence up. Right? Then we have, then I get an error, -2, which is good, because that's a problem. And then I have -1 and -0.5. So it's down here somewhere. 0 and -0.5. And it's going a little bit above here, so it's going to go like this. A little bit above and back down. Could I find this accurate little bit above? Could I find out where that is? We've done it before. What is that? When you go up, touch something, come back down, what is that? Yeah, the maximum. So I could go second trace, maximum, number 4. I could go on the left side of it, enter on the right side of it, enter, enter, and it gets me -0.5 and -0.444. So it just goes a little bit above. So I can actually find the maximum of that one if I want to, just like I did in quadratics. Then I'm going to go back to my table. I have 2 and 0.25. I have 3 and 0.1. And the rest just get really close, like this. They're almost 0. So this cow's going to run along the fence here, and then it's going to run along the fence there. So the drawings you can pull directly from your calculator, right? It gives you every value. You just go along the way. Does that make sense? Have I lost people? I know it's the first time you've drawn these graphs, and often you guys don't even know how to use your calculator for the table of values. So I want to make sure you're okay. You guys okay? All right. So the last thing we have to do is invariant points, and invariant points are the hardest part of this because we're going to be using quadratics, and they don't always factor, so sometimes we're going to have to use quadratic formula. So not always the best. So we're going to do invariant points last, and on a test I can ask you to find the invariant points on a reciprocal. Invariant points, which we're going to practice before the test anyways every day, are y equals 1 and y equals -1. Now, what do we always put them into? The reciprocal graph or the original? The original because it's easier. You could put them into the reciprocal, but they're going to get you the same thing, so why put it into the harder one? So I'm going to go y equals x squared. My original is y equals x squared plus x minus 2. I'm going to put it into there. So I'm going to go 1 equals x squared plus x minus 2. And negative 1 equals x squared plus x minus 2. Now linear is easy because you're just going to isolate the x. But quadratics, how do you solve a quadratic? Everything to one side set equal to? 0 every single time. Okay? So with linear, you're just trying to isolate x. With quadratics, you have to get it equal to 0. So the first thing I'm going to have to do for this one is subtract the 1 over. So I get 0 equals x squared plus x minus 3. And then I hope I can factor it and solve. If I can't factor it and solve, I have to use the quadratic formula. I'm reviewing quadratics right now anyways. Is there anything that multiplies to give me negative 3 and adds to give me 1? No. So I have to use quadratic formula. Whatever's in front of my x squared is a. Whatever in front of my x is b. Whatever at the back is c. The quadratic formula, I'm going to write it over here. It's on your formula sheet too, so you don't have to memorize it. It's also on both the 30-1 and the 30-2 formula sheets, so you never have to memorize it. Ever. It's on both. Well, you might in university, but you don't have to. Negative b plus or minus the square root of b squared minus 4ac all over 2a. As you can see, it's on both formula sheets, so it's equally as important in both classes. That's 1 over dash 2 to know how to use the quadratic formula. So we're going to go fill it in. We're going to get x equals negative b is 1, plus or minus the square root of b squared, which is 1 squared, minus 4 times a, which is 1, times c, which is negative 3, all over 2 times a, which is 1. And then I told you to do what's underneath the radical next. So you could type the whole radical in. You're going to get 1, we're going to type what's under the radical in. So you're going to get 1 squared minus 4 times 1 times negative 3. And you should get 13 over 2. And this is the exact value. If I asked you for exact values, that would be the exact value of x. And your two coordinates would actually be negative 1 plus root 13 over 2 and 1. Negative 1 minus root 13 over 2 and 1. If you wanted to sketch that, you'd have to type in your calculator to get a decimal, right? But I'll ask for them in exact values. So those are your two invariant points when y equals 1. Yep.
Would it be 1 minus 12? Or how do you do it?
So it's going to be 1, and then this is going to be negative 4 times 1 times negative 3, which is positive 12. And so it's 1 plus 12, which is 13. So if you just type it in exactly like this, without the square root symbol, just bracket 1 squared minus 4 times negative 1 times, and you have to use a negative sign, negative 3. If you type it in exactly like this without the radical, it'll give you 13 as well. So double check. Then we have to do the negative 1. So we add 1. We get 0 equals x squared plus x minus 1. Does anything multiply to give me negative 1 and add to give me 1? Nope. So I also have to use quadratic formula for this one. You know what's better than 1 quadratic formula? 2. Right? Right? No, not really. That's 1. This is my A. This is my B. This is my C. I'm going to end up getting something and negative 1 and something and negative 1. Those are my two coordinates. I just need to figure out what those somethings are by using the quadratic formula. So I go x equals negative 1 plus or minus the square root of 1 squared minus 4 times 1 times negative 1 all over 2 times 1.
Sounds off.
Really? I'm wondering what that sign is. Hola. All right. So we're going to get -1 plus or minus, and then it's 1 squared, which is 1. Minus 4 times 1 times -1 is 4. 1 plus 4 is 5, so we get root 5 over 2. So those are my two answers. -1 plus root 5 over 2, and -1. -1 minus root 5 over 2, and -1. So linear is a lot easier than quadratic. Quadratic is much more work to get your invariance. Okay? Oh, crap. Christian, do you have your textbook here? I think Bill has not brought mine. Oh, I see Anna has hers on the floor. Okay, so your homework. It's so warm in here.